Okay, welcome to Nested Loops. We're doing POODR Chapter 9, first half or more, depending on how long this runs. So Andrew has this chapter, and we'll just start with him. So go ahead and present. Oh my God, infinite scroll death die.
What a way to start. So this chapter is about designing cost-effective tests, and it's a long chapter, so I split it into two parts. So this is part one. We start with something called, I have a typo up top. It should just say designing cost-effective tests. And the main takeaway from the intro is that the true purpose of testing is to reduce costs. However, a lot of us are used to seeing costly tests in that it's hard to write good tests. And Sandy Metz's argument is that you have to be good at OO design principles and incorporate those design principles both within the code and within the test. She put down a few steps, a few skills needed. One, able to write easy to change code, meaning things are nicely compartmentalized so that, compartmentalized in the sense that it's being dry, as in don't repeat yourself. And so wherever one change is needed, it can easily be traced to whatever is depending on it. Two, defer decisions. Try not to make speculative methods, saying that, oh, possibly in the future, I will need X, Y, and Z methods. Let the requirements guide what methods you need. Three, refactor easily, kind of going with the easy to change code. And then four, the main point for this chapter is create high value tests. And so I made up a little diagram which goes to write easy to change code, evaluate change via tests. Next. So next section is what are knowing your intentions. So the intentions for writing tests is immediate bug fixable feedback. Just as a personal anecdote, I love immediate feedback. It's one of the best ways of learning, and to learn new and hard topics, having quick feedback just allows just going through as many different types of opportunities of creating something. So that's something I really like about testing, is that feedback. Living documentation. Tests and code. I've heard it said that you can rewrite your code. You can just have a test and be able to generate the code that passes the same requirements as long as you have the same test, that you don't really need the code, as long as you're building to pass all the tests. So that's, in a sense, it's almost like a recipe, but a little bit more complex. Deferring design decision via interface. Like before, where we don't have speculative methods, the interface is what's publicly available to any other user or object, so that any other methods that you don't see as being a public method as something to ascribe to your object should help you in making your decisions when saying, do I really need this method, or should I wait and see what changes the client or the requirements make in the future. Ability to support and document abstractions. Abstractions is a little bit hard for me to describe. So I asked Forrest if you can. I'll look through my notes, but as far as abstractions, Well, I know that we've gone through what a concrete object is and what an abstract object is. That one of the qualities or one of the characteristics of concrete is that it changes quite a lot frequently, and whereas an abstraction is something what I can only give an example of, like Ruby has a class called string that acts with methods that we're all familiar with, and it's very much constant and it's very dependable. Um, so as far as supporting abstractions, it helps to say how likely is this object going to change and how we can reduce that change through our tests.
Yeah. In that part, she's talking more about abstraction in general. And I think it's easy to confuse the idea of abstract versus concrete class. So primarily abstraction she's talking about here with design is, for example, the beginner level OO abstraction is kind of modeled like a real world object. It's just easy when you have real world objects. Like I have a bank account and, a checking account and a savings account, which could be subclasses of account. And so that's the kind of abstraction she's talking here. The beauty in the test is that you can show support document. When we talk about documenting, if you're right, and this is sort of the big difference in my mind with RSpec versus test unit. If RSpec tries to make it via the language, if you read the, describe this, it, or context this, specify, whichever ones you use, if you read the words and actually try to make them make sense, describe checking account, it should allow interest at the end of the rate, If you pay attention to the words and you want them to read right, the test's set up to express your intention, and the whole one assertion per test thing that some guys emphasize, that kind of just helps make your test more granular. The problem when you write test unit and you do like def test something is there's nothing to stop you from testing everything in one method. It's just a big jumble of does it work, does it not work? There's no describe this object in this condition, it does that. So when RSpec sets up that language, it tries to encourage you to organize your specs in a way that reflect both your intention and kind of this structure. Right? So you can see what I'm talking about, like a checking. Describe bank account, context, checking account. When checking account is overdrafted, I charge, the late fee. You see how those words describe the structure, describe this hierarchy, describe this condition. You can do that in test unit, but nothing kind of, not that RSpec forces you, it kind of pushes you towards it. If you want your English to make sense in RSpec, you kind of tell a story that makes sense, which includes the abstractions. I've said, I've written in the past, def, test, object, and then, I just put a bunch of crap that tests everything that I can think of. Right? And again, if you do test first, you also tend to granularly approach things in a way that even test unit will do it. It's just that nothing in test unit forces you to put this structure that RSpec tries a little harder to do. But abstraction, to support and document the abstraction sort of here's kind of like that, as opposed to abstract class versus concrete class, which is a different thing. But this is the word abstract, but isn't really abstraction. Okay, go ahead, sorry.
No, thank you. So, and then next we have exposing design flaws. Good statement to go with that is when the code is bad, testing is hard. I can imagine testing being hard with good code as well, but just another reason why some of us, myself included, find testing hard is that my coding isn't the best, and if it was, I would imagine testing would be a lot easier. Which shows.
She talks about later, you should test first where possible. This is the one spot that test first cleans up the easiest. If you write the test or you have any code, you kind of very immediately expose your dependencies. And that's really what makes testing harder. It's like you write a bunch of code and now you have no hooks with which to test, right? If the code doesn't exist, you write, oh, well, I've got an object, and when I do this to it, this happens. So now you have your expectation, and you go, oh, crap, to get this to work, I need a database and a this and a that. Well, at the time of having no code, you go, oh, well, then I have to inject a database, and I have to inject this, I have to inject that. And then that's the point where you make it easy to inject, because none of it exists.
Right.
And then you inject the stub version or the test or mock, or depending on which testing double language you use. You put the testing double in then instead of the real thing, or you use the real object, doesn't really matter. But the dependencies become obvious at that point. The problem, what happens when you write tests last, you write all this code, you have all the dependencies, and you never made any way to inject or change this. Now you have this thing that you can't control the state. Now how do you test it? Or you don't even have an output. But maybe it just draws to the screen because you never wrote a test. So, well, now you can't figure out what's on the screen. So this is the one part when we say code hard to test. By default, if you test first, it's kind of easy to test because you have no code. So you write the test and then you structure the code in a fashion that makes it easy to test.
She does say that later on, that one of the benefits to writing the test first is you immediately make your code reusable. And for the same reasons you were saying, that go through tests first, you realize you need something, you inject it, right? Whereas before you already have something written, and now you have to try to pull everything apart so that you can test it. Her main point is that for tests to lower costs, both the underlying application and the test must be well designed. Kind of be a better coder means that you'll be a better tester, which means that we all benefit from learning design principles. The main goal would be, going forward, is writing loosely coupled tests about only the things that matter, kind of reiterating the statement of you want to test the things that you want your object to do. In a sense, don't test for methods that no one asked for and no one needs. In a sense, like a test shouldn't know exactly how the method works as long as the method works, in a sense. In this case, it's almost like the ends justify the means as far as testing goes. So the more that resonates with your test, the less coupled the code and the test is.
I think the closer thing, or you're going to talk about the details. Let me see the next slide. I'm going to say something on the goal, but let's look at the next slide. Actually, right, let's test one, test two. Okay, here now. Is this actually covered it? Go ahead.
Okay, so in the next section, we have knowing what to test. And one of the main things is just we shouldn't test every single little thing that we can think of, because that makes it much more fragile, that any change that we want to do in our code breaks and make our tests fail, and it just becomes a nightmare to maintain. What she has down is that when we write less tests, we remove test duplication. And then another focus is that we want to deal with the objects by the messages they respond to. So on the right, we have a little diagram of what is within our testing domain. And for this object under test, we're focused on the messages sent and the value returned. And we do this through the public interface, but notice that we're not aware of the things inside of the object under test.
Are you talking red?
No, nested loops. We're doing
okay, sorry. So are you free at 4 or 4:30
yeah.
for meeting?
So as far as our tests go, their only concern is this public interface, where we have these two arrows where the object responds to a message and then returns a value. And tests either assert that the value has to be within some range, or assert that it's not, that it doesn't, or that how do I say it? There has to be a comprehensive suite of assertions for a set of messages that then can say that the test has thoroughly covered all possible outcomes with regards to the object and its behavior. And then on the left, we have a scale between most stable and least stable. And I brought up earlier the distinction between concrete classes and abstracts. I guess abstract classes or just abstractions, where I confuse abstract classes and abstractions. But with, in this case, as I understood it, was that when we have a public interface, that's more stable because we have a set of methods that we can rely upon, saying that we expect the object to respond to these methods. Whereas if we say we expect this object, and I mean, and that includes like that object has methods, whereas with a public interface, we can swap out objects as long as the interface still behaves like it should. I feel like my explanation might not be the best. Forrest, what were you saying before that you had something to say about the goal, or was there?
Oh, well, some of your goal was like knowing what to test, right? Usually a couple tests the things that matter. And I was going to say primarily where you get that is through the public interface and via the message, kind of your chart, when I see the charts there. The message is, so there's some debate in the testing community, do you test private messages? Ideally, if your code is good, you should be able to test all those cases through the public interface. In practicality, either your code isn't that good or sometimes the situation is complicated enough that you don't. And so like some of our code, has really complicated things. Right. It's easier to test the private method. Let's say there's like 26 scenarios. Easy to test 26 scenarios in private method where I can put variables, but maybe the way the code is and through the public is I'd have to set up this complex state for each one. So it's harder, in fact, sometimes to test something through the public interface for stuff, in the case of, let's just say that there were 26 scenarios, internal thing is expected to do. It's easier to do that. It begs the question, well, if it's so hard to set up, maybe there's something wrong with your code, which is maybe true, may likely be true. It begs the question whether if I'm testing 26 of the private methods thing, if that should be a public method, maybe it should. There's things there. But in general, when she talks about unnecessary tests, sometimes people don't test. Like ideally, when you have the public method, you obviously have the happy day scenario where that works, and probably at least one fail scenario where it doesn't work, and there's edge cases. I think if you limit it to that one, that's pretty good. I can't, depending on how you read it, I can't see a problem with testing all the cases through the public interface. But that being said, there are some people, and Ruby especially allowing you to be able to test private methods.
If I can interject.
That's something that Java guys don't do unless they go through certain gyrations, simply because they can't test the private methods directly unless they come up with some, again, the gyration for normal stuff, but just knowing what to test. Yeah. Once you put the slide and I saw public interfaces, so I don't have to say anything.
So something about testing private method. A lot of time when you feel like you have to test the private method, what it is, it's either not a private method or some code needs to be extracted. Generally, it's like the sign, like, well, I really need to test this. Is it important? If it's important, it's probably a different object, a different class, and all that kind of stuff. Yeah, that's about it. All right, keep going.
All right. So, following knowing what to test comes I have something called types of testables, which is a funny word. So there's two types of testables. There's incoming messages and outgoing messages. And I can quickly go through this nice little figure that Sandy has in her chapter. We have foo and we have bar as our two objects. And we can see that to the left of foo are incoming messages. To the right of foo are its outgoing messages to bar. And bar takes those outgoing messages as incoming messages. So hopefully that helps, what is an incoming and outgoing message. And it all depends on whether the object is acting as a sender or if it's acting as a receiver with respect to that message. So incoming messages. They are for a receiver, I believe, comes through the public interface. So messages that an object would receive are public methods that the object has. And for incoming messages, when you're testing them, you would want to observe the state returned by that object. We go into this in more detail because that's the scope of this first part of designing cost-effective tests. The second type of testable is outgoing messages, where we have two types. Query. Queries are, I think of queries and I think of sending a SQL command and getting the state of something. But queries are, in a sense, you're expecting a return. You're expecting something returned to the sender, whereas commands are more like something somewhere out there is being changed by the object that the command was sent to. And that doesn't necessarily mean that anything's getting returned. So, so to distinguish the two, queries returns a value, something, and a command changes some other aspect that it has that is within its scope. So it could be like turn on the lights. And, I mean, I can imagine a command having a return saying like, oh, the status is on or something. But that's like, for me, a bit of a gray area. The takeaway for me is that objects should always interact via public interfaces. I don't know if that's just being redundant with how we view objects, but I think it's a good point to get across that it's better to think of their interactions as interactions with a public interface rather than an object knowing too much about another object, in a sense. Any thoughts?
Yeah, I mean, that seems like it makes sense. And I think what is surprising times are that when you don't do that. It's like one of those no duh, but then you'll probably easily come across tons of code that doesn't do that. So it's worth emphasizing. Oh yes, only use the public. What am I trying to think about? For example, back in the day, with like less advanced computers, games would write stuff that depended on undocumented features in the OS, and of course, because they're undocumented, they're chosen to. They can fail. They can change at any time, and suddenly your game stops working because your Commodore 64 updated something or something like that. That's kind of the example. That's kind of the same model. Oh well, I'm calling this private method. Running this method, but instead of looking at the results, I'm checking the state on the object. Like, I'm not using what the method tells me. And it's like, you think it doesn't happen, but it happens. And so I think just keep in that interact only through public interface. I don't know. It seems like it's no doubt, but you'd be surprised at the times it gets violated, especially in Ruby where you can.
So the way I think it's interesting how she does the command test is by actually changing the class under test, and where you can pass an observer that helps the test. the only reason for the observer is to pretty much provide some testing functionality.
Yeah.
I think that's interesting. That's something that a person wouldn't do, but maybe there's, you know, like she talks about, you know, sometimes you have to verify that stuff has changed. Or, personally, I think like if like in her example, she got gear with set cog, set chainring. Gear will have the test itself. The chainring has changed. I don't know. I feel a little iffy about it, but I can see her point.
We kind of jumped forward. I'm assuming he's going to cover code stuff.
Yeah.
Down. I should paging down to see how far your example is. Okay, go ahead.
Thanks.
Yeah, just an outgoing. Yeah, you're like 6-7 pages down.
It looks like I skipped a section. Nope, here it is. So I went a little bit further. Oh no, never mind. Okay, so the next section is, well, subsection is knowing when to write tests. And like I said previously, for a novice coder, writing tests first means that the code that we write from that test means that it's reusable. It sounds nice to say it. I guess what that would mean is that there is no encumbrance by some strange dependence on something else. It means that anything that it depends upon can be stubbed easily. So she has a few sets of points to 2 different types of people. To the first type, for the novice programmer, tests force applications to be reusable. Testing lowers overall cost, meaning that in the future, as things change and methods have to be updated and to meet the requirements, testing allows to make sure that other methods and other objects that depend upon those methods are still working properly with a very low overhead. As far as just running tests go, it's not too complicated to see what passes and what fails. And testing helps, I think, apply OO design principles, meaning that it's great to have design principles in your code, and tests, good tests have, or you can incorporate good OO design principles in your tests. So as far as a novice goes, that just solidifies design principles even more, because it gives you 2 places where you can apply those principles. Then for the experienced programmer, which was when going about creating the applications, the test first mentality is the go-to. After a spike or discovery, trying to figure out what works best. So examples for this is hard for me, but I can imagine some new feature needs to be implemented, and there's different options to go about implementing it, and you would want to just scope out like what's the best way of doing it, what does it need to do, and then once you figured out which one was the best way to go about it, you start from, okay, I needed to do this, and I'll write the supporting code and doing a TDD approach to it. And the second point would be that the goal is to create applications that are well designed and have acceptable design coverage. It was not easy for me to needle out all the main points she was trying to tell the experienced programmer. I felt like it was more geared to advice for the novice programmer. I guess to our experienced programmers, Forrest, Diego, were these? Does that resonate with you? This like testing first helps.
I think so. My thoughts on the way you should probably approach this as a beginner, to test first, not necessarily programming, is you should probably strive to do it all the time to build up the skills. And then once you have the skills, you can kind of back off where you go, oh, you know, this doesn't make sense. And doesn't make sense really is cost. Like somewhere earlier, Sandy says, you should write tests first whenever it makes sense to do so. That's a very vague thing. I think you should strive to do it as much as possible until you find out it doesn't make sense. And sometimes it doesn't. I think more often than most people recognize, it actually does make sense. That being said, it's like, you know, when I used to write a lot of production code, I used to write a lot of test first. A lot of the code I write now is very exploratory. So I often don't write it because I'm just trying to guess or look or feel out something. But the second something gets hairy, writing tests will be quicker. Well, it'll be cleaner code, but I'll be able to say, hey, here's these 6 cases. Well, I'll write 6 tests and I'll make them pass and boom, it works. Right, so that's kind of go to when it's clear. Yeah, sometimes it's clear. Sometimes it's good to flesh out the design. But this, something she mentioned earlier in the book is, oh, if you're experienced with OO and design, test first is easier because you know the structure your code should look like. Like you can come up with this interface first get-go. And it never struck my mind because I learned test first after a long time of programming. So it's like, oh yeah, well, the API I would like to see is this. So even though it did exist, I could come up with something reasonably quick. And sometimes when I don't, I have to think, and I have to go off and I might spike some code I figure out what that interface should look like. Where it's like, I think for the beginner programmer, it's like, I don't even know what to write. And that is the hurdle that makes it harder for beginner programmers as well as beginner test first. It's like, oh, I want to write a test first, but I have no idea what this should look like. It's like, oh, never struck me. Oh, you know, if you've been coding for a while, you probably have a sense of what things should look like. So when you're writing from scratch, oh, I want it to look like this, possibly because you saw something like it before or just experience. But I would say if you don't know how to test first, a lot of it's not intuitive. A lot of the habit is hard. It's like, I think the best way is just nose down and force it until it becomes habit. And then you can say, oh, you know what? This would be easier with a GUI test. Or it's one of those things. And there was a debate, I think it was mostly Twitter. Someone said, hey, a lot of the Agile Ruby community was very test first diehard. And someone asked Kent back, hey, test first all the time. Test, TF. And they involved the effort. Test all the effing time. Something like that. That's what it stood for. And you know, the hash rockets and the ThoughtWorks guys were kind of pushing this. And someone asked Kent Beck, they said, well, do it when it makes sense. And he goes, oh my God, you mean don't test all the time? Well, you know, it's the cost. If it takes you 6 days to write a test, but you could throw together a cucumber for hitting it from Selenium in like 20 minutes, does it make sense to Kent Beck? And they're like, oh my God. But of course, then the problem happens is people think like, oh, Kent Beck said I don't have to test all the time, which means then I test 2% of the time. So I lean towards the, hey, test 101% of the time, and in practicality, you end up testing 70% of the time. There's always the ideal and the reality. It's like, you know, do your jump shots so you get 20 out of 20, because when the game comes, you get, you know, 2 out of 10. Right? So, but if you never practice jump shot, then you get 0 out of 10. So I see that with test first. Strive as you're learning to do test first 101% of the time, and then in practicality, maybe you get 70, which is pretty good. But that's right. There's insights that come where you go, oh, don't test this because you can quickly assess, oh, it's going to take me 3 days to write, and I don't have 3 days because the boss is breathing down my throat. So, all right, that's kind of my thought.
Thank you. So the next section is knowing how to test. And I call it the list of 2s because there were 2 of everything here.
That's the rule of the Sith.
Yes, for every master, there's an apprentice. So 2 testing frameworks in Ruby. There are Minitest and RSpec. And we kind of spoke about this, how RSpec helps with abstractions, mini-test, the def test does this, and just cram as much as you want within that. There's no restrictions as far as that goes. Sandy Metz uses mini-test in this chapter. And there are two approaches to testing, which we kind of were talking to, but we didn't really flesh out yet. So there's BDD, behavior-driven development, and TDD, test-driven development. So BDD creates objects at the boundary first, then continues inward by stubbing methods and objects as needed. Whereas TDD works from the inside out, creating tests for domain objects and then reusing these newly created objects in adjacent layers as you build out. So in this chapter, she has a simple diagram as well, where we see BDD kind of goes from the outside in. And I'm going to say that the outside is the public interface, where we say this object should respond to delete or destroy. And then we stub out whatever we need to make the test pass, and then we go one layer in to actually create the objects that we were stubbing out before as we build inwards and making sure that eventually we have a complete object. But then I would think that TDD, not sure, would it be like we know that this object depends on this one like abstract class, and so we'll build out and then we'll finally flesh out the public interface at the end. That's a question that I was just thinking of when I was reading this over.
This debate, if you look at Fowler, Mountain Fowler is a good place to look for a lot of stuff. The classicist versus the mockist, that's closer, that's more accurate than the BDD versus TDD, where many BDD guys are more mockists. There's a book, I forget, it's by Nat Price and another former thought worker, something like crafting code through object-oriented by testing, something like that. I'll dig up that one. That's the book that kind of defined, quote unquote, the mockist philosophy, which a lot of thought workers really push. And it's the outside in, mock as you come across stuff you don't have, instead of losing your train of thought from this guy. And then the classic mocks is, less mock magic. And I kind of lean more towards that where possible, because you can mess your mocks up. That's what you learn. It seems so great, but the problem is when you over mock everything, you can make a mock that doesn't act like the real object, and that comes to bite you. And I've felt that pain. I know other people felt that pain. I imagine Diego's felt that pain. So I lead towards using the real object as much as possible. And the beauty of Ruby and RSpec is I can take a real object and just change a small item on it. So I can use the real object and then just tweak one small part of that one to get the answer I want. So that's kind of the best of both worlds. But yeah, there's a big, Martin Fowler has a big old article about mockers versus classicists. Classic mocking. But yes, in general, to avoid mockers, use a real object as much as possible. Sometimes you don't have that. If you don't have it, do you divert to build that object, or do you mock it? Maybe you do both. Maybe you mock it now when the real object comes, you put it in. But who has the time to do it twice? Pretty much nobody. Go ahead.
Okay. And the final list of two. There are two categories of testing, and I like this one. It's very sarcastic. There's the first category is object under test, and the second category is everything else. And tests should know things about the first category and ignore everything in the second, which is, I really like that. That was very nice to read. It's like I was expecting, oh, I wonder what we're gonna do with everything else, and she just says, ignore it. Don't worry about it at all. Which is great. That's kind of like one that relieves the burden of like, oh, what should I test? Should I test all these other extraneous things? And it's like, no, just test just the object. That's all you're worried about. Sorry. Okay, so now we're in the new section called testing incoming messages. I wrote API, application public interface, but it's every incoming message is part of the object API. And so she had this nice little table that has your two objects, wheel and gear, and what they respond to or what they sent, and then whether or not they have dependence. So wheel has only one incoming message, which is diameter, and diameter does have dependence. Gear has two incoming messages, gear, inches, and ratio, and has one outgoing message, which is diameter, and its outgoing message has no dependence. As far as dependence goes, if an incoming message has no dependence, that's part of the criteria of whether to delete those messages. And luckily, all of our incoming messages for both wheel and gear have dependence. So there's no reason to delete any of those methods. And for now, I'm just focused on incoming messages. The next section will go through outgoing messages. And oh, yeah, here we go. Deleting unused interfaces. All incoming messages should have dependence. That is, all incoming messages should have some object as a sender. Yeah. If an object if an object expects a message, but there's never another object to send it, then there's no reason why that method should be part of its public interface. And to have a test for it is just doubly useless.
This is a place where BDD helps. If you go top down, you only implement things that the guy above it calls. Part of bottom up front testing becomes, oh, this is the bottom, so I'm going to think of all the things it can be used at. So when you do bottom up instead of top down, which makes sense for a library. The library has to anticipate a bunch of stuff, but people will go and they'll write, and they may TDD it, but they may have methods that never get called by the higher classes. But when you TDD, you argue you start from the cucumber level and then you go all the way down to the test. So you only ever have a method that a higher level class asks for. So you're basically saying use our spec.
Yeah.
Use our spec correctly.
So yeah, so if you do have a method that has no dependence, what we said before, it's speculative. We're trying to guess what the future might ask of the application. And as far as agile, that is a waste of time. To better future-proof your code, make sure that you're able to change it easily so that when there is a new requirement, it's easier to implement that new method rather than try to incorporate that method in a hard-to-change way. And yeah, if there are any incoming messages with no dependence, Sandy says delete them and do not test if you do not delete them. So I think we still have more. Okay, next subsection, proving the public interface. A little bit of what before I had on the little chart that I made was that an incoming message for the test domain, you send a message to the object and you expect the object to return a value. So to do so, you're asserting its return value, but now we're doing it in every single situation that we can think of. It could be 26 possible scenarios that the object might encounter. I have here, this isn't making a lot of sense without the code. So here we have the code as written. This was similar to in chapter 3, where we had wheel and gear, where in this code, is this version of the code, wheel is being called out explicitly within gear inches. In that chapter, we learned about injecting dependencies and removing this kind of rigid structure. for her first test that we're seeing here, we see that she writes it in mini test and calls it test calculates diameter, where we just see that the new diameter that's created when we have a new instance of wheel is 29, given the parameters 26 and 1.5. I'm not sure what 26 and 1.5 are calling out. They're calling out the rim and the tire. So a rim of 26 inches and a tire of 1.5 inches means that the diameter of that wheel should be about 29 inches. And I imagine it passes very nicely. I haven't seen this method before, but I guess it's to say plus or minus 0.01. Let's see. Wheel has no dependence. Gear depends on wheel. So when we see the next line of code for test, we see that we don't actually see it, but we know that gear is calling out a wheel object. We can actually see it in the code, where when we call gear inches on gear, it actually creates a new wheel object and takes the parameters from the instance variables and then calls diameter on that new object. Her main point is that wheel could be, or some other code could be, well, that wheel could be very expensive to call. It could be very resource heavy. And to go about having something within the code that can't be stubbed out easily is a drawback. So to finally make sense of what I wrote, tests make it apparent when there are hidden risks in code design. The hidden risk would be that wheel is not something that gets injected, but instead calls out explicitly this new wheel instance. And so what we do next is that we create an object that might respond to diameter. But before that, keep doing the wrong code. We do isolating the object under test. So as the code currently is, gear is bound to wheel. To break that binding, we have to pull out the object from gear, which would be wheel, and allow it to be passed as an argument in the initialize. Now gear has changed its expectation from requiring a wheel object to an object that responds to diameter, something she calls as a diameterizable, which isn't really easy to say, but it is something easily doubled. So before I get to that last point, let's just look at it. So what that was saying was that she rewrote the code, so now gear no longer calls out a wheel and creates a new wheel, but actually just says, I expect there to be an object named wheel that responds to diameter. So that when we write our test, we can now pass the wheel object to gear. And that allows us to, in my opinion, it quickly, to me, it just jumps that I want to just create some struct or some small object, some double, that just responds to diameter and does what diameter does. But because we go about this in such a way, she instead kind of takes a little detour and says, well, we'll change diameter in the wheel class. And now instead of calling it diameter, we call it width. So this is more of like a teaching moment, because now that when we run the test, we get an error. So the test works very well. It lets us know that the code changed so much that it breaks, because now we have an object that no longer responds to diameter. It just responds to width. So that, yes, in the future, if we were going to run gear inches from gear, we get something that breaks. And our test lets us know that. So without having to debug anything, we know exactly that, yeah, diameter is no longer a method that wheel responds to. So in the case where gear calls diameter, but wheel now responds only to width instead of diameter, the test works perfectly, letting us know that there has been an actual change to the code that makes the test fail.
So it's 10:59. I think this is a good place to break. Related to that one, this is a reason why if you over mock, you wouldn't catch it. If you made an open struct, it would still respond to diameter, just would give you nil. But it
Right.
I mean, it might cause a math error, but and this is more vigorous if you mock an object. This is kind of why I prefer with Ruby mocking stuff to put a real object, to put wheel. And maybe I mock something on the wheel so I get a number that I want, but the rest of the interface stays the same. And if you put a mock in it, if you stub, double, whatever, and it doesn't act like the real object, the real class, then you can miss that. So you have tests that still pass. And that was one of the pains of over mocking and the mocking families. Though I don't know if I haven't tracked it. I know RSpec does that, but there's probably some mocking frameworks that try where you pass in the class and it tries to emulate the real interface. I know Java had that for a number of years where they have mocks that you pass in the class, and so your mock will look to the class it's supposed to be emulating to tell you, oh, this interface doesn't exist. That would make this less painful. But in my mind, in Ruby, why not just use the real object? And if you have to somehow change complex behavior, you can put the stub or the mock method on that real object to change just one small part and have it act like the other object. The other reason I like the real object is just because your one test expects this one thing doesn't mean that some other thing on real isn't called later. I'd just rather use the real object as much as possible. But yeah. All right. Any questions? We had two Michaels, but now we have one Michael joining us from outside the normal group. Sam is here. Don.
I just one observation. Like the example that she says, oh, I'm gonna change diameter to width. You know, now it fails, right? It actually would have failed even earlier, but like the thing that she did is isolate. In the isolating of the object on the test part, is it kind of made it obvious that there was a tight coupling between the test and the two objects.
Mm-hmm.
So there was, the test tested gear and indirectly tested wheel,
mm-hmm.
right? And now it kind of makes it, okay, let's imagine now that we're passing like this wheel like or diameterizable roll object, and then after we can change it for whatever we need. So like I think that was like kind of not that effect that now fails, because it would have failed anyway in when the code changes, but it kind of pointed out. I don't think like the test points it out, but like you kind of, when you do the test, you kind of have to ask yourself the question, because like, how many dependencies are in this class, and how I can extract them out, or how can I make it obvious that that is dependency, and maybe they should be injected. That's it.
Mm-hmm. All right. Well, if there's no other questions, comments, we'll wrap it up here. And then we'll do you think another one is enough, or you need like two?
I think one more is enough.
I'm looking.
All right.
16, I'm just trying 17, 18, 9. There's like about 19 Kindle pages worth here. All right. Well, Andrew will pick up next time. We'll see if it takes more than one. It looks like it's mostly code, but maybe that's where all the discussion is.
That's true.
I think I look at this code and I go, oh, this would be easier done on RSpec. in a lot of ways. But there you go. Okay. Well, great. So thanks for joining, and we'll see you in 2 weeks. Ooh, Infinity Gauntlet Scroll.
And beyond.
Half of everyone is dying now. Half of all programs are like dying from the Infinity.
Gone. Me too.
Gone. Phasing away. But I don't want to go. I don't want to go. Mr. Stark, please.
Bye.
Bye.